we are here and we'll be discussing the GATE XLP 2023 chemistry solutions. In the next question, they are asking us that in this molecule to be planar, the number of plane of symmetry present. Now, if I draw this molecule, generally when we talk about the plane, this question is from the chapter Stereo Chemistry. This is basically asked from the colligative properties. Then this question is basically asked from the topic periodicity. Then this either you can say name reaction or you can say the reagents, anything. In this question, these are two entities. Among the two, if I draw the structure, I'll draw the structure in this way. The methyl is above the plane, the hydrogen will be below the plane. Here hydrogen is above the plane, the methyl is below the plane. So, here if I draw the plane along this part, this way. So this plane will cut along this, it will cut this also, it will cut this also, which means that the number of plane of symmetry present in this entity is 1. This along the diagonal. So number of plane present will be 1. The next question is the dipole moment of BRF2. The mu is given as 1.42 d. The bond length, that is the distance, is 176 picometer. The atomic charge distribution Q of the molecule is. So what will be the value of Q? We know dipole moment is equal to charge into displacement, right? Now this charge will be equal to dipole moment 1.42 d divided by 176 picometer. Now we have to convert this unit. How can I 1 becquerel? 1d is equal to this, so I'll write 1.42 into 3.34 into 10 raised to the power minus 30 coulomb meter divided by so this molecule will then be divided by 176 into 10 raised to the power minus 12 meter. From this meter to this meter, we will cancel out and then we'll solve this entity. After solving, we'll get Q is equal to 0.16 coulombs. And since we are asked to calculate the atomic charge distribution Q, so for the atomic charge distribution, I'll simply divide. I have to calculate how many number of molecules are there, the atomic charge distribution in the molecule. So to calculate that, this will not, to calculate that, simply what I'll do, this should not be the, before that one step more will come. So from this I'm getting the charge, overall charge. And we know that 1 electron corresponds to 1.6 into 10 raised to the power minus 19 coulombs charge. And we have to calculate the atomic charge distribution. So how I'll do? I'll simply solve this equation. After solving, I'll get 2.65 into 10 raised to the power minus 20 coulombs. I'll divide that entity by 1.6 into 10 raised to the power minus 19 coulombs, and then when I'll do so, I'll get 0.16 as the answer. So this will be the atomic charge distribution in the molecule. Now we'll come to the next question. The next question says, consider two different paths in which the volume of an ideal gas is doubling isothermally. First thing we have to write is the process is isothermal, okay, and volume is V1 is V, and the volume is doubling, that is V2 volume is 2V. Firstly, when we talk about the reversible expansion, okay, then the work done is reversible. So work done reversible is minus 2.303 nRT ln V2 by V1. Or I should write here, because I have written 2.303 log V2 by V1. This can also be written as minus nRT ln V2 upon V1. Simply nRT ln 2V upon V. This will cancel out, and this will be minus nRT ln 2. When I'll do the same for the irreversible expansion, I'll write work done irreversible will be equal to minus P external V2 minus V1. This will be simply equal to minus P 2V minus V, which is equal to minus PV. Minus PV can also be written as minus nRT. Now this is my first equation. This is the second equation. Equation 1 divided by equation 2 will be minus nRT ln 2 divided by nRT minus. When I'll do so, what will happen? Everything will cancel out, charge will cancel out, and we'll just be left with ln 2. So our answer will be ln 2. This is the question. Now in this question, we are asked to calculate all these things. So first, they have asked us to calculate. So first, before doing all the calculation, if I come to manganese, H2O6 2 plus, this basically means that the manganese is having 2 plus charge. 2 plus charge means it is having D5 configuration. Water is a weak field ligand, so the water will be high spin. High spin means all orbital are singly filled. If all are singly filled, what I can say that n equal to 5, that is number of unpaired electron is 5. And if I calculate the Bohr-Manganton BM magnetic moment, it will be under root n plus 1, n plus 2, under root 5, 5 plus 2, excuse me, under root 35. Under root 35 will be around 6, that is 5.92, which means for E the correct option will be 1. So this is 2, then I'll eliminate this. This is 4, I'll eliminate this. Now for this, if you see that E corresponds to 1, E corresponds to 1, here G corresponds to 3, here also the G corresponds to 3, which means that this corresponds to this, that is nickel chloride. If you know that nickel chloride is present in the nickel 2 plus form and we are having the chloride ligand, so it will form the sp3 hybridization. Now if we discuss the H1, H option is nickel CN4 2 minus. ठीक है, तो nickel is present in the 2 plus state. 2 plus basically means that is the D8. And if we talk about D8, in this case the ligands presents are strong field ligand. Strong field ligand means that the ligands will be low spin. Low spin basically means that all the electrons will be paired. And if all the electrons are paired, this means that the species is diamagnetic in nature. So the answer for H will be 4. So this is 2. This will eliminate out. The correct answer will be A. Then we have to come on this molecule. If I draw the structure, chair form, this will be present above the plane. Here the Cl is present basically above the plane. Okay. In the another entity, this is again a cyclic ring. This is present above the plane. Here the chlorine is present below the plane. And this and this togetherly are resulting in the formation of this complex in the presence of a base, right? So this is getting formed. Now if you can see that this is the hydrogen atom present here and here this is the H atom present here. So if I take a base, this will be a base OMe minus. So if OMe minus base comes, it will attack here, it will abstract this hydrogen atom, this will donate its electron here and the chlorine will be removed. Okay, as simple as that. But if we talk about this process, again here the OMe minus molecule will come, it will take the hydrogen atom. If hydrogen atom donates here, then the removal of this will be very difficult process. Okay? Because here the hydrogen and chlorine are not present in the anti position. Since they are not present in the anti position, which means here no reaction will take place, and if no reaction taking place, the product formation की rate will be very slow, which means that the K1 will be much faster than K2. First point, this is clear. The most stable conformer of P gives the product this. Yes, this is the correct option. So this was all. Now when we come to the next question, the next question is the hard soft HSAB principle. The correct order for the solubility trend will be, so Ag positive is a soft cation and I minus a very big size anion, it is also a soft cation. So the soft one will form a good bond. Okay, they will undergo a good covalent bond formation, or basically a good and a favorable bond formation will take place, and the bond formed here will be very stable. So when we talk about the solubility, so if the bond is very stable, hard interaction and soft interactions are generally favorable. Okay, so if they are forming a stable bond, the stable bond basically means that the hydrolysis of the solubility of this AgI bond will be very difficult. So basically the softness is directly proportional to the polarizability and is inversely proportional to the solubility in water. So the correct order will be A, because this is very strong, highly stable, will not be that much soluble, but this is not forming that much strong bond, it will get easily solubilized. And the another option, again similar reason, lithium bromide, the lithium ion and the bromine ion, and the lithium ion and the fluoride ion. So here the lithium are the hard species, the fluoride ions are also the the fluoride is also a very small size in ion, and if it is a small size, so this will not be the correct answer. If you see, most of you think that if you look at lithium, that it is very small in size, and if you compare the other one, so if we look at this trend also, don't make such type of mistakes. Just always remember this, that again the lithium one, the lithium is hard, the lithium and the fluorine is also hard. Hard interactions are the stronger one. If the interactions are stronger, this means that they will form a strong bond and they will be less soluble. So the correct option will be the B one. The next is that which of the following compound will be, which will result into the formation of this type of species. Like, you know that this is the Grignard reagent, and if it is a Grignard reagent, it will basically be a CH3 minus nucleophile. The CH3 minus nucleophile will basically attack at the carbonyl center. Now you know that if we talk about the B option, in the B option what I'll say, that if this type of CH3 minus unit attack, then this is acting as a good leaving group. So when this unit will attack at this carbon, this will bond will shift up, then it will this bond again come back and this molecule will be leaving. Then the product will be this double bond oxygen CH3. Then again CH3 minus unit will come, attack here, this bond will open up, undergo hydrolysis, and once it undergo the hydrolysis process, it will result in the formation of your OH, CH3 and CH3 unit, which means that this is the correct option. Similarly, this unit is already, see this and this is similar. So the product answer will be B and C. Now here there is no leaving group, so this cannot be. And here if you attack at this position, then this will be a leaving group. And the product has the phenyl group. Okay, we cannot remove this group. So B and C will be the correct option. Then the number of radial nodes for the valence orbital of uranium 3 plus ion. Okay. We are given the uranium 3 ion. Atomic number is equal to 92. Electronic configuration, if I write, it will be radon, 5F3, 6D1, 7S2. When it is present in the +3 oxidation state, it will be radon, 5F3. These 3 electrons will be lost. Okay. Now if you look that they are asking you the from this radial note, if you have to calculate the formula to calculate the radial note is equal to n minus L minus 1, the value of n equal to 5, the value of L equal to 3, 5 minus 3 minus 1, which will be simply equal to 1. So number of radial nodes will be 1. The next question, This question is from the electrochemistry topic. Now we know it's given that E naught is equals to 1.10 volt for the following reaction. The equilibrium constant we have to calculate. What will be the equilibrium constant? We know at equilibrium delta G naught is equal to, at equilibrium delta G naught is equals to minus RT, or more specifically, since the number of moles are not mentioned to you, I can say that it is equals to minus NF E naught cell, which can also be written as minus RT ln K. If I equate them, I can write ln K is equals to NF E cell or E naught divided by RT. Number of electrons, when we talk about this reaction, zinc when converted to Zn2 plus, it will lose 2 electrons. And similarly, so this is the oxidation half cell, this will be the reduction half cell. Copper 2 plus will be gaining 2 electrons, converting into copper solid. So how many electrons involved? 2. Faraday 96485 multiplied by E naught cell. E naught cell is given to you as 1.10 volt divided by R value, gas constant 3.14, and the temperature given to you is 298 Kelvin. When you do the calculation, if you write log K, then this whole value will be further divided by 2.303. Okay, in case of log K, here we basically write 2.303 log K will be equal to this. This term has been brought here, which means that the log K is equal to 37.201, and if I take the anti-log, the K will be 1.58 into 10 raised to the power 37. So the value of Y will come out to be 1.58.